The meter bridge is a simple electrical device used to measure the unknown resistance of a wire or component. It works on the principle of a Wheatstone bridge, where the balancing condition is achieved to find the unknown resistance. The device has a 1 meter long wire fixed on a wooden base with a scale, along with a jockey, galvanometer, and a known resistance. It is widely used in physics experiments to understand the concepts of resistance and electrical circuits. Aim of the experiment: to determine unknown resistance and specific resistance of a wire using meter bridge. Apparatus required: meter bridge. Jockey. Key. Battery eliminator. Connecting wires. Galvanometer. Resistance box. Unknown resistance wire. Formula: unknown resistance X equals R 100 minus L by L, where R is a known resistance and L is the length of the wire from one end to the null point. Specific resistance: ρ is equal to pi r square X by L, where R is the radius of the wire, L is its length, and X is unknown resistance. Principle: the principle of a meter bridge is based on the Wheatstone Bridge circuit, which states that when the ratio of two resistances is equal to the ratio of another two resistances, there will be no current flow. P by Q equals R by S. Here P is equal to R, Q is equal to X, R is equal to L, S is equal to 100 minus L. Therefore X is equal to R 100 minus L by L. Experimental procedure: arrange the apparatus as shown in the circuit diagram. Set up all the parts like the galvanometer, resistance box, and wire exactly as shown in the diagram to ensure everything works properly. Connect the wire whose resistance is to be determined in the right gap between points C and B, ensuring no loops are formed. Attach the wire you want to measure in the correct place. Make sure it doesn't twist or overlap with itself, as this could cause errors. Connect the resistance box in the left gap between points A and B. Place the resistance box, a tool that gives known resistances, in its proper spot. This will help balance the circuit later. Make sure all other connections are as illustrated in the circuit diagram. Check that every wire and device is connected, as shown in the diagram, to avoid mistakes in the setup. Remove the key K in place of the 5 ohm resistance in the resistance box. Remove the key to allow electricity to flow. The 5 ohm resistance is used to start testing the circuit. Gently touch the jockey to the left end, then to the right end of the bridge. Touch the jockey to both ends of the wire to check if the galvanometer is working. It should show deflections in opposite directions, then the connections are correct. Move the jockey gently from left to right across the galvanometer. Let T be the null point where the jockey touches the wire. The jockey is a metal pointer used in a meter bridge experiment. It is gently moved along the meter bridge wire to find the null point, which is where the galvanometer shows 0 deflection. This indicates that the potential difference across the known and unknown resistances is balanced. Note the position of D to determine the length of AD is equal to L. Similarly, the balancing length CD is equal to 100 minus L is noted. The position of the null point D is measured on the meter bridge wire. The length ADL represents the portion of the wire where the potential difference is equal to the known resistance. The remaining part of the wire, CD, 100 minus L, corresponds to the unknown resistance. Take 3 sets of observations by changing the value of the resistance. To improve accuracy, the experiment is repeated at least 3 times. Each time a different resistance is used and the null point is found again. This helps in reducing experimental errors and obtaining a reliable average value. Note the observations in tabular form. The recorded values, including the position of the null point, balancing length, and resistance values, are noted in a table. The value of unknown resistance was calculated by the formula X is equal to R 100 minus L by L. Then, average value of unknown resistance is calculated. Here, X is the unknown resistance, R is the known resistance, L is the balancing length, and 100 minus L is the remaining wire length. The formula is derived from the principle of the Wheatstone Bridge. The length of the unknown resistance wire was measured by using an ordinary scale. The physical length of the wire used in the experiment is measured using a meter scale. This is important for calculating the specific resistance or resistivity of the wire. Using a screw gauge to measure the diameter of the wire, and readings are noted in the tabular form. Then the specific resistance was calculated by the formula Rho is equal to X pi R square by L. Precautions. All the connections should be tight. Do not keep the jockey in contact with the wire for a long time. Jockey should not be dragged on the wire. The current should be passed only while testing with the jockey. Results. The measured value of unknown resistance X is equal to 6.317 ohm. The calculated specific resistance of the material of the given wire Rho is equal to 0.48 into 10 power minus 6 ohm meter. Thanks for watching Pathfinder 6. Like, comment, share and subscribe to my channel.